recording. There we go. So variables in Java, you got integers, floating points, different range of values, right? 8, 16, 34, 64 bits. The reason why you have all those, number one, if your numbers are small, you don't want to use a whole lot of memory for them. For example, if you're tracking integers that are all in the range of like, maybe 1 to a million, you don't need massive floating point numbers for that. You can use much smaller ones. If you're keeping track of a character set, for example, well, in typical character sets, there are only 16 bits worth of numbers, so 65,000 or so different character possibilities. So again, you don't need to reserve a whole lot of memory using different sizes. Okay, but other times, if you have numbers that have a lot of decimal places, for example, your 64-bit floating point number can keep up to 17 decimal places. And if you want super precise decimal math, yeah, you might choose to use those. Anyway, other thing, faster computations. In general, integers are processed much, much faster than floating point numbers. So that's a consideration as well. So again, the reason why you have these different variable structures, so you can use the right tool for the right job. You don't want to allocate extra memory or require extra CPU cycles to process stuff. All right. So there's 4 integer types: byte, short, int, and long, and 2 floating point types, float and double. Now within the family of integers, basically the number of bits indicates the number of possibilities. So a byte has 8 bits, each bit is a 1 or a 0, so there's 2 to the 8th possible numbers, or 256. Likewise for a short, there's 16 bits, 2 to the 16th, which if you're an old school computer person, you would say, oh yeah, I know that number, that's 65,536. That's how many possible numbers there are. An integer, an int rather, is about plus or minus 2 billion, and a long is a very big number, very, very big, suitable for, things like the current federal debt, stuff like that. So the 2 floating point numbers, float is a very big number up to, if I recall correctly, plus or minus 10 to the 38th. Double is an insanely large number, plus or minus 10 to the 308th, which is a number so absurdly big, I can't even come up with a possibility of why you would need it. I'm sure someone has, so I just myself can't. For example, the estimated number of atoms in the universe peaks out at somewhere at like 10 to the 90th, right? And 10 to the 308th is so infinitely larger than that. Yeah, so I don't know what you'd use it for, but it's there if you need it. There's a couple other primitives. Boolean is a true false one, and char, which is essentially a number that prints out as a text character. We'll introduce those later in the course. Not much later though, in the next 2-3 weeks. Okay, so integer types store an exact number in binary format. Okay, so if you're interested, again, the range of numbers is -2 to the n minus 1 to 2 to the n minus 1 minus 1. And that's some math there. So I'm going to do this in Paint. So for example, simple one, a byte, 8 bits, 2 to the 8th is 256. So 256 possible values. Now, those 256 possible values in a byte, what's called a signed number, which is the default in Java, ranges from -128 to +127. So 128 is 2 to the 7th, so 2 to the n minus 1, and 127 is 2 to the n minus 1 minus 1, right? 128 minus 1. Okay, and the other ones are similar, right? They're all basically like for an integer, well, I can give like for a short, right? Again, 16 bits, 65,536 possible values, and they range from -32,768 to 32,767. Anyway, so there's a range of numbers, but it's basically centered with almost as many numbers above as there are below the 0. Okay, so in integers, one thing that's not immediately obvious, the highest bit indicates the positive or negative. For example, if you're doing this byte, right, -128 in Java is going to be encoded as 1, 0, 0, 0, 0, 0. Is that all of them? That's all of them. Whereas plus 127 is going to be encoded as 0. Okay, so this is binary, right? Now, you don't need to know binary for the course. I'm just bringing this in to explain what's going on. So you understand if we had regular decimal math, 99 plus 1 equals 100, right? So basically 099 plus 1 becomes 100, right? The nines turn over. Well, same thing here. If I add plus 1 to this, it's going to equal out as this, right? 1 and a whole bunch of zeros. And this can cause some problems because why? Whoop. I'll show you. Because of course, this number, which is 128 in binary, Java will interpret that for a signed number as negative 128. So with integers, you have to be real careful. If you get close to the boundary, it can flip over like that. It can do what's called an overflow. And, you know, there's a predictable way that it happens, but you have to be aware of it and be careful that it doesn't happen in most cases. Okay, so practical consequence, any math operation involving integers is going to throw away any excess bits, right? So for example, if I take this number, right, a byte can hold 256 possible values. If I take 16 by 16 in regular math, it equals 256. But if I take a byte that's 16 and multiply it by another byte that's 16, the answer will be byte version of 256, which in binary looks like a 1 followed by 8 zeros. So the only thing that's going to get kept, all the, well, I gotta say, the 256 will get discarded. You'll be left with 0. So again, integer math is a little strange. Let me do a demo on that in Eclipse. I don't want to, this, my class yay is silly, so we'll get rid of that. But we'll do numeric variables. So we'll do fun with numbers, and we'll give it a main method. And I'll do a very quick thing here. Okay, so I'll do byte math. Okay, so I do void byte math. Oh, static void. Ooh. Static void byte math, and I'll send along 2 numbers as arguments. So I'll say 16, 16. Okay, and this will accept 2 bytes, byte B1, byte B2. See, it doesn't like that. No, it thinks they're ints. Yeah, okay. We'll typecast those. Don't worry about exactly what I'm doing here. It'll make sense in a moment. There we go. Okay, so what I'm doing is I'm telling these 2 numbers are bytes of 16. And I'll show you what it is. Okay, system.print line B1 times B2 Did I miss something? Oh, I need the plus there. Okay, this is going to print out the equation. So B1, 16 times 16 equals, and here we'll have the product as a byte. Oh, wait, what's it doing? Oh, right, because, sorry, haha, it's still an int. So I'm going to do this, byte. There we go. Ah, okay, so it drops that number. But if I leave it, right, so I'll do a text for this. So I'll say byte math. And then on the other line, I'll do int math. Let's do it this way. Just want to get that line. Okay, so if I do int math, do this, I get rid of the byte typecasting, and then we'll keep that 256. Boom. And there we go. So byte math is different from int math. And again, can be a little bit confusing. Next thing, floating point math. So floating points numbers, they contain an integer portion and a decimal portion. And even if the integer portion is 0, it's still there. Now, the actual way that it's encoded is pretty complex, and there's no really good reason for you to learn what it is. But if you're interested, I posted a link to it. But again, there's no good reason to go in and learn that unless it's, just because you want to. Now, with just like scientific notation, right? We know how this displays. So smallish numbers, you'll just see the number and the decimal places, like 10, for example, displays as 10.0. But bigger numbers, like 6E27, where you don't want to see all those zeros, will display as 6.0E27. Now, the practical consequence in Java for floating point numbers often only approximate the target value. Okay, so in binary math, just like in decimal math, there's no exact way to represent 1/3. You can get real close to it. You can have a whole long string of, 0.3s, but it's never going to exactly equal 1/3. It's not going to equal that fraction. Same thing in Java, right? You can't exactly represent 1/3 in Java. There's a whole bunch of fractional numbers or decimal numbers that you can't exactly represent. So what happens? Well, it means there's always going to be a little bit of approximation error. And I can show you that. I can show you, let's do some floating point math. So I'll do FP math. Okay, and we'll send in a double, I don't know, 2 point, let's see. What's a good number to do? 0.9, 0.9. Okay, 0.9 times 0.9 should be 0.81, right? But it's not going to represent well in Java. So we'll do this. Static void FP math. Okay, double D1, double D2. And we're going to do system.out.println. Okay, double, whoop. Sometimes it wants to overwrite what you do. Double math plus D1 plus times D2 plus. Okay, so let's run that, right? We have our byte math, and we'll have our floating point math afterward. Boom. Okay, so double math, this one is displaying exactly, but if you look closer, you will actually see that it's not exact. It's just dropping off a lot of stuff, or sometimes it happens to land exactly, but it doesn't quite do it. Okay, so let's do another one. Let's do 2.0 divided by 3.0. Let's see how that goes. Okay, so here we have, we'll do the division. 2.0 divided by 3.0. Oh, I'm still multiplying. All right, we'll do that one more. Okay, and again, all right, see, again, we see a bunch of 6s, but it's not going to be exact, right? It's going to get truncated off here. We need like 6s going out to infinity, and even then we would never reach precisely, what's the number I'm looking for, 2/3. So there's always going to be that little bit of inexactness. Now, sometimes, again, yeah, it might happen where all the stars align and you get zeros at the end. But more often, what happens in reality is something like this. Like if you do 0.9 times 0.9, what probably happens in Java is that the end result is something like 0.81, 0, a whole bunch of zeros, and then a 1. And it decides just not to show you that last number, right? Or you might get likewise 0.8000000009 or something like that, or 8 or 7. We'll eventually, in this lecture, we'll see some of those kind of rounding errors come up. Okay. So that's it. And you have to be careful with doubles for that reason. I mean, you can get the results and print them out, but you don't want to depend on doubles being exact numbers. So moving on. So here's our variable summary slide. Some very big numbers. Okay, byte, short, int, long, float, doubles. Very big numbers, some of them. Okay, Now this list is important because it's in sequence. We'll get to that in a second about what the sequence is. But if you think about the way this is set up, you realize that any number above can be exactly represented by a type below. For example, a byte number can always be represented by a short number, right? So a short number, the range of possibilities encompasses all the possibilities of a byte. Likewise, the long encompasses all the possibilities of an int or a short or a byte. Likewise, any double variable can represent any of these, right? It's just the decimal part is going to be a 0. So here, right, we don't have that many we don't have that many zeros, right? So 2 billion is 9, so this probably has like, 18 zeros. 18 zeros is a lot less than 308 zeros. Okay. So, key thing to keep in mind, the way this list is ordered, any number above can be fully represented by a number below, which means you can convert numbers going down the list without losing data. But if you convert numbers going up the list, you might lose data. For example, if you have a double number and it has any decimal portion at all, if you try to convert it to an int or any integer type, that decimal portion is going to be lost. Okay, that'll be important when we get to it. Now, in Java, variables can exist in two different ways. Some of it we've already demoed in the code. So one way is a persistent attribute of some class, which is called a data member or a data field. We've seen this in some of our examples. Another one is a temporary value or a local variable, which is created for use in a particular method, becomes garbage after. Okay, so go back to Eclipse here. In this method, right, say byte math, this method, when it runs, it needs two numbers. So what happens, Java sends these two values, they get stored in memory, right? Space gets allocated for them, they get stored while the method is running. At the end of it, the method doesn't have anything to do with these anymore. They're discarded and become garbage. The garbage collector comes back and recycles that memory and says, okay, some other operation can use that memory when they need it. Okay? But if I put them up here, for example, if I put, as byte B1, B2, if I put them up there, then they would be persistent ones. Okay, so I could just do, I wouldn't actually need to reference them here. All right. I'm going to get rid of that for now. Whoop. We'll keep that though. Okay. So variables exist in two different ways. You can have persistent ones that are data fields as long as the object exists, or if it's a class variable, as long as the class is in the program, which it always will be, that data is always there. If it only exists in a method, like the parameters we saw, then it's a temporary value. It only exists while the method runs. Once the method is done, it gets chucked, it gets thrown away. Now, just like objects, variables have to be declared and assigned a value before they can be used. You have to declare them so the IDE knows what kind of variable you're talking about, right? If I just talk about B1, for example, in my code, and I haven't declared to the IDE that B1 is a byte, the IDE is not going to know what B1 is. In general, two possibilities. If it is a data member, right, if it is a data field belonging to an object or a class, they'll get assigned a default value of 0 or 0.0 if they're floating point numbers. But still, programmers shouldn't depend on that. But that's what Java does, right? It'll probably continue that way in the future, although you never know for sure. The other one, local variables do not have default values. So when you create the object, you automatically have space allocated for any of the data types it contains, right? So if it has a double, for example, Java knows a double is going to occupy 64 bits, is 8 bytes. It's going to allocate that memory for that variable. It's not necessarily going to fill it up with anything unless you tell it to, right? So the value will be 0, but it'll definitely have a place there and you can access that variable. On the other hand, local variables have to be assigned values. They don't have default values. They don't exist in memory until you go to the trouble of actually declaring them, okay? So, for example, go back to Eclipse. I'll make a, static void local variable. Okay, so if I do something like this, I'll do int I, and then in my method, I do system.out.println I. Okay, you'll see there'll be a problem. Okay, let's go ahead and call this local variable 1. Oh, damn it! No, I can't. You're right. Never mind. That is going to work because I've declared it here. So yeah, that's not the right way to do this. That's fine. I'm going to do this. Int I2 system.I2. Okay, here I get the error. Okay, so if you look, it says local variable I2 may not have been initialized. And in fact, it hasn't. I have not assigned I2 a number. So this one, this is fine. It has a value. I can use it, right? Whenever the method calls it, right? Whenever that method gets called, it's going to send along an argument, and that'll get converted to the parameter. So I will always have a value. But I2, on the other hand, I2 doesn't. It's local variable, it doesn't exist. But if I want to do this, I could do int I. Okay, and here I could send along the value I, right? I could say I make a new fun with numbers dot I. Okay, this value exists. When I create the new object, whatever that new object is, I can send along its I attribute. It'll be initialized to 0. Okay, so if I do this, I would print out I. All right, I'll call it I2. That's fine. Okay, it's going to get printed out as 0. Ta-da, there it is. There's the 0. But again, if it were a local variable, you have to assign a value to a local variable to get that to work. Okay, so declaration syntax, just like objects, variables get declared by giving them a type and a name. For example, the line int x, that statement means x is a type int variable. Double y means that y is going to be a type double variable. So style conventions, data members are generally the first statements inside a class definition, often alphabetically. Data members of the same type are declared alphabetically on the same line. So I have some examples in a moment. So generally, when you have a class, you're going to put your data members at the top. So, and if you have multiple ones of the same type, typically you're going to put them on the same line to save space. So double A comma B and int x comma y comma z. So if I create an object of the class numbers, it's going to have 2 doubles called A and B and 3 ints called x, y, and z. Likewise, you can declare variables inside a method, and then they're local to that method. So if they're at the start, right, if they're outside a method, but they're in the class, they are object variables. Anytime you create an object of that class, it'll have that data. If they exist, if they're declared inside a method, and that includes parameters for a method, then they only exist in that method. They don't exist outside.
So if you were going to use these variables, would you declare their value in the, you could declare their value in the class or in the method, right?
Which variables?
So if you're going to use the double and say you have like
which double?
A is equal to like 6.5,
sure.
You could declare that in the class or in the method, correct?
Right. So if I did that here, right, let me slide. If I did it here, equals say 0.5, then that would mean anytime I create an object of that class, it's going to have a default value of 0.5 for that variable. Okay. If I do it down here, right, if I say right, I'll do it here, 0.5, well, that's just declaring n, right? If I mention a here, by default, the IDE is going to think, oh, this a is the same as that a. And it gets a little weird. If I have a parameter here that's an a, then there's something else, but yeah.
So if you declared a in that method as 0.5 and you used another method.
If I assigned it a value?
Yeah, if you assigned it a value of 0.5 and you used it in another method, would you be able to assign a different value in that method, or would it hold constant? Okay, cool.
Oh, yeah, that's not a problem.
Awesome, thank you.
Yep. Yeah, you can always do, you know, you can do different values in different methods. You could do multiple different values in the same thing, right? It's syntactically valid to say something like a equals 0.5, then follow it right back up with a equals 0.51. You can do that because sometimes, you know, you might want to. Okay. All right. So to assignment, we'll cover this, and then I guess that'll be that. So unlike objects, primitives don't need to be created separately from their declaration, right? So when you have an object, first you declare it, then you create it. Now you can do that in one step, but you're still doing both of those things. For variables, you don't have to. Primitives, you declare them, and then if you want to, you assign them a value. Okay, so reason is, very simply, anytime you have a primitive, Java knows exactly how much memory space it's going to need for it. So number one, you don't need to figure out how much memory space you need. The type determines how much you need. And number two, the memory involved is usually pretty small, right? So an int is 4 bytes. That's usually not a big deal. The way, you know, people use Java, it makes more sense to just go ahead and allocate the memory. It would actually cost more memory in the code, forcing people to put in extra statements, you know, allocating memory for that. So it's actually a memory saving device, not forcing people to do that, not forcing the programmer to do that. Okay, so again, assignment could look something like this. Double A equals 0.0, B equals negative 1.6. We have our three ints, 0, 1, and 2. Likewise, in a method, we could give our numbers whatever values are legal. So for M, which is an int, we can give it a, you know, our good friend 2 to the 16th. Or for N here, we give it a very large negative number, negative 10 to the 308th. Very large number. Okay. Yeah, so this is a good breakpoint, I guess. I will mention, yeah, this is a good breakpoint. We'll come back, we'll do some math on Friday, and we'll probably finish a lot of this stuff. The stuff at the end, the last several slides are practice problems. I might kick them off to people to practice over the weekend, see what happens. Okay, so what are our key takeaways? We'll go through that. We'll do our takeaways. Okay, so key takeaways from today's lecture. Okay, number one, there are numeric variables, also called primitives. Okay, called primitives because they're not objects. So primitives are not objects. Okay, they are the data. They don't have the data and methods. So objects have data and methods, classes have data and methods. Primitives are just the data. They're the building blocks of the objects. Okay. There are 6 pure numeric types. Okay, we've seen them: byte, short, int, long, float, double. What else? I mean, that's the big stuff at this point. Have an idea of the sequence, have an idea of the approximate values, but you don't have to memorize that. For our integers, the last 2 are floating point numbers. They have decimals. Okay. We covered some other stuff, I guess, the secondary details, right? Beware of overflows with integer math. Like we saw, 16 times 16 equals 0. And then with decimals, you have different problems. Beware of approximation with decimals, okay, with floating point numbers. So that's it. If you get that, that kind of makes sense. You're feeling good about this. I think we're in a good place. I guess the last thing, you know, we talked about local versus data field or member variables. So remember, local variables, local to a method, they only exist while the method is running. Data fields, data members exist as long as the object exists. Okay, so I think that's good. Questions on any of this stuff? I'm going to stop the share. I'm gonna stop the recording. Okay, here is one thing. Okay, a couple of questions about the lab. We have to follow the same instructions on the code, right? Right, exactly. I mean, the exercise is a walkthrough. Do what's in the exercise, and you should come out with the correct code at the end. How do you save the source code? Okay, you should, let me answer that. So if you want to save your source code on Eclipse, right, chances are it is in whatever your personal stuff is, your personal folder on your device. So you scroll up and find the folder that has your name on it. And in your workspace folder, you'll see a list of projects. Okay, so if you have more than one, you'll see them here. It's in the source folder there. This is where all of your .java files are. But yeah, I'll post a little instruction thing. The other thing you can see is when you start up Eclipse, I'm gonna get rid of this. Okay, when you start up Eclipse, you'll see this folder initially, and it'll say, here's your workspace. Okay, and if you went with the default option, but right there, that's the file path. So C users dlundq1, that's me, workspace, that's the folder where my stuff is. Okay, but it should be in the SRC folder in your project, SRC for source code. Okay, how much syntax should you know by now? Basics, you should be able to, number one, write a class, right? Understand that, not like a whole class with a bunch of stuff, but you know, the magic keyword, class, whatever, okay? 2, write a method header. Okay, so the standard format, return type, name, params in parentheses, okay? And 3, declare and create objects. And number 4, we just got today, declare and assign variables. If none of those seems especially scary to you at this point, you're probably in pretty good shape. Okay.